Hello students, welcome to my channel. I hope that you have watched my all videos on the states of matter and what I have taught. If you have not watched it, please watch that and subscribe my channel and press the bell icon. Today I am going to start a new chapter, that is atomic structure. You may know about what are atoms. Okay. Atoms are something, they are the fundamental blocks of matter. In biology case, you may study about the cells. What are cells? This makes a tissue, and tissues make an organ makes a organ system makes a body. At the same case, the atoms are a basic fundamental building blocks. Okay, these are we cannot see with our naked eyes. Okay, and the existing different kinds of matter around us made up of atoms. Let it be in, it may be in solid state, it may be liquid state, or it may be in gaseous state. In all the three states, all the three cases, you may say that the atoms are present. In this solid state, atoms are very close to each other. In liquid state, they are somehow close to each other, and gaseous state, they are far away from each other. Okay, in all the three cases, atoms are present. According to this structure, okay, what are atoms and what are their structures, been many scientists and put their views and postulates. First postulate and theory was given by the Dalton atomic theory. Okay, Dalton was born in Dalton has made these theories in 1808. Okay, in the made of theory of Dalton is known as the Dalton's atomic theory. What he says that every substance is made up of several indivisible particles. He says that atom is an indivisible particle. What means indivisible? Means if a substance is this, okay, if this is a substance, I can divide this into 2 or 3 parts. Okay, I cannot divide it into 2 parts or 3 parts. It is an indivisible particles. Okay, the substance is in very indivisible particles, and they are known to be as an atom, but later it was disproved by some scientists. I will say you in later stage. Then he says that an atom is an indivisible particle. After that, he says that atoms of same elements have same property, but atoms of different element differ in mass, size, and element. Of course, you may note that if I am having a group kg of apple, okay, if I'm having a 1 kg of apple, it will have, all the apple will have the same property, all will have a sweetness. Okay, all have a particular same size, most of them will have a same size. If I'm taking a 1 kg of say orange, they will have a different taste and they will have a different shape. If I'm taking a kg of tamarind, they will have a different shape, they will have a different taste. Okay, so all these three will have a different taste and each shape. So the same case in elements also. If I'm taking a nitrogen, they will have the same. They am taking oxygen, they will have the same properties. Okay, so that is named as atoms of same elements have same properties, but atoms of different element differ in mass, size, and chemical properties. Next, you may know that about these atoms combine together in a fixed proportion to keep compound. They combine together to form in fixed proportion, they combine. Okay, in fixed proportion. For example, water, what is the proportion? 1:2. Okay, if I can say, sorry, it is 2:1, not 1:2, it is a 2:1. Okay, now coming to the point of atom. Atom, what is an atom? Atom is the smallest particle, as I have said earlier. It is the smallest particle, and many postulates were given by the Dalton. It says that neither be created, and it gives two laws on that. Law of combination. According to the law of combination, okay, but he given a law called law of combination. Law of combination. Law of combination say it has two laws. Okay, first is law of conservation of mass, and second is law of constant proportion. Laws of conservation of mass says that mass can neither be created nor be destroyed in a chemical reaction. I am showing this in with an example. For suppose I am taking a water molecule. It is a basic example. Okay, I'm taking a water molecule and I'm eating it. Okay, I'm taking a water molecule and I'm eating it. Then they get dissociated into H plus and OH negative ion. Okay, H plus ion and OH negative ion. They get dissociated into H plus and OH negative ion. So here if I'm taking how much hydronium ion is present, 2 hydronium ions are present. Oxygen has a 1. Here H ions are 2 and oxygen ions are 1. There is no change in the mass. So mass can neither be created nor be destroyed in a chemical reaction. Here in left hand side also I am having 2 hydrogen and 1 oxygen atom, and in right hand side also I am having 2 hydrogen and 1 oxygen atom. This says that law of conservation of mass, that mass can neither be created nor be crystallized in a chemical reaction. We will see about the law of constant proportion later. First, constitution of an atom. What does an atom constitute? You may note that in Dalton atomic theory, it was not fully described about does it have electron, proton, neutron, which are the constituent particle of an atom. As Dalton has said that atoms are indivisible particle, okay, but it also have a division part. If it is an atom has a proton, neutron and electron. It is a division part. The belief that the individuality of an atom has been destroyed with the discovery of several phenomena like radioactivity, which has been revealed the atoms are divisible and made up of fundamental particles called as electron, proton and neutron. It is however, it is also a smallest particle. Now also it is considered as the smallest particle. In biological term, I can say, for explaining you, I can say if there is a cell, if I am having a cell, the cell also consists of organelles. A cell is smaller itself, but it also consists of organelles. Like we consist of organs, cell also consists of organs, and we called it as a cell organelle. So cell organelles, what are cell organelles means? For example, mitochondria, Golgi apparatus, it all comes. I'm not involving in this. I want to tell just that if this atom is smallest particle, but it also consists of the particles which can be divisible. Okay, several phenomena like radioactivity which reveals the atoms are divisible and made up of the fundamental particle called electron, proton and neutron, where electron has a negative charge, proton has a positive charge and a neutron has a neutral charge. Okay, it has equal number of positive and negative charges. However, it is a smallest particle. Okay, discovery of electron, proton and neutron. As it was not said, as I have said earlier, that it was not being detailedly said by the Dalton atomic, it was not said by Dalton atomic theory. J.J. Thomson observed the pressure of discharged. Okay, what does he mean? Okay, according to I want to first describe about the Thomson model. What is the Thomson model? What is the Thomson model? Suppose it is he shaped an atom as a watermelon, cutted watermelon. Okay, if there is a watermelon, I am cutting it in a circular shape. What I can observe that it has seeds. Okay, it has seeds like this. It has seed. Okay, and there is outer whole covering like this, outer cover. So this outer cover, which is the wall of my watermelon, is consist of only positively charged, and the seed which is embedded in this fruit consists of named as negative charge. Is it clear? The outer cover is the positive charge and the inner seeds are termed as a negative charge. Okay, this is the structure of Thomson model. So what does the Thomson says about electron, proton and neutron? He said that I potential is reduced to 10 to the power minus 6 atom stream of negative charge particles called electron originated from cathode, and the stream of cathode rays. This rays travels in a straight line, cause mechanical motion, produce X-rays and fluorescence, and deflected by the electrical magnet. First of all, I want to say that the water cathodes and it's an electrodes. Okay, For example, to say you this about this, if I'm taking a bath, okay, I'm taking a bathtub and I'm taking an ionic solution. What is an ionic solution? For example, NaCl, salt solution. I can say it is simply a salt solution. I'm taking in a salt solution and I'm dipping two electrodes. Okay, one electrode consists of positive charge and another electrode consists of negative charge. The positive charge is termed as anode. Okay, positive charge is termed as anode and negative charge is termed as cathode. Okay, it should be noted that that anode with a positive electrode liberates cations. Okay, many people confuse on that. They think that cations means negative charge because it may be liberated from cathode. No, cathode as consists of negatively charged. It is an electrode consists of a negative charge and it releases anions, not the cations. Okay, anions are negatively charged particles and cations are positively charged particles. So what here it says that the cathode, the stream was called as cathode rays. These rays travel the streamline which causes mechanical motion. These are some particles, electron, proton and neutron, discovered by mass Thomson. Electron was discovered by Thomson, proton was discovered by Goldstein. Okay, proton was discovered by Goldstein and neutron was discovered by Chadwick. What are their charges? Only you must note about the electron minus 1.6. It is useful for calculation. Okay, electron, it has minus 1.6 into 10 to the power minus 19 coulomb. Okay, coulomb is the unit of the charge and here it is as electron is negatively charged, I write here negative charge, and proton has a positively charged, I write here positive charge. Okay, next, what is the position? Position is too simple. The main model of an atom was fully given by Bohr model. Okay, you must keep it in mind that the main model of an atom at the last, first where it was whom, that was Dalton gives the theory, after that Thomson, after then who, Rutherford, after then it comes to a Bohr model. This Bohr model is considered into consideration. Okay, if I am taking the Bohr model, how is the Bohr model found? At the center there is a nucleus. Okay, in the center there is a nucleus and there is a circular orbital. Okay, we can consider it like a planets, how the planets are rotating around the sun, I can consider. But in solar system, every orbital has each planet, only one planet in each orbital. So but here that not the case. At first orbital it consists of 2, second orbital 8, third orbital 18, that's go on. So where is the location of proton, neutron, electron? Proton and neutron are present in the nucleus. Okay, nucleus consists of proton plus neutron. You must remember this. Nucleus consists of proton and neutron and electrons are moving around the orbital. Okay, electrons are moving around the orbital. Later I will teach you about this electron also. Heisenberg uncertainty principle, according to Heisenberg, was a scientist who said that the moving electron loses energy. Okay, moving electron loses energy and then it falls into a nucleus. Okay, I will deeply say about this. I will teach you what postulates he have given, what theory he has made according to an atom. Okay, now is this positive rays. Okay, this cathode is a it is a negative electrode and it releases anions. Okay, anions means negative charge. So J.J. Thomson produces this electron with the use of cathode. Take X-rays, fluorescence. Okay, cathode, and he gets a electron. By this way, J.J. Thomson has been discovered. J.J. Thomson discovered the electron. Next comes under Goldstein. Goldstein, what he does? He did a anode rays. Anode, I said anode is a positive rod. okay, and it releases positive ions. And what are positive ions according to atom? These are protons. Okay, what are these are protons. Defected the magnetic field, this all. Next, Chadwick discovered neutron, an electrical neutron subatomic particle having a mass 1839 times the electron. As normally, what is the work of a neutron? Neutron is stable, and suppose in during the increasing atomic mass or atomic number, you may note about the periodic table, which is in atomic structure in this chapter only. Every element has a particular atomic number. So as the increasing atomic number, the size increases down the group, and across the period it decreases. Across the period it decreases, down the group it increases. So what does the neutron plays an important role in stabilizing the electron? Okay, for example, if an atom getting increased with the charges, okay, if some electrons have been given, if it taken, okay, it stabilizes. Neutron helps in stabilizing, it helps in neutralizing the charges. If negative charges increase in an atom, so the positive proton been added, so to get neutralized. If proton get increasing, neutron electrons have been added to get neutralized. Okay, next is ions. What are ions? Ions are the particles. Take atoms as a whole neutral base. Every atom, it is noted that every atom is a neutral particle. Okay, what is an atom? Atom is a neutral one which consists of positive and or negative charge. For example, sodium consists of positive charge, Cl consists of negative charge. Okay, this I'm okay. For example, Na. Okay, Na has +1 charge. Why it has +1 charge? I am writing is atomic number, that is 11. Okay, for I am not considering +1 or -1. It has a atomic number of 11. Now what is its configuration? 2, 8, 1. What does it mean? For suppose it is an atomic nucleus, I am making an orbital. First orbit consists of 2 electrons, second orbital consists of 8 electron. 1 2 3 4 5 6 7 8. Okay, it consists of 8 electron. And the third, okay, it is completely filled. First orbital must have 2 electrons, second must have 8 electron. 8 plus 2 10 completed, more 1 left. Okay, I am making it in L orbital, that is 1. Okay, I am making it L orbital 1. So every element, you must note that every element who gives an electron or takes an electron. Why it gives or takes an electron? It gives or takes an electron to get a noble gas configuration. Okay, noble gas configuration you can say, या फिर to complete the octet, to complete the octet, to complete the octet. Okay, suppose here 2, 8, 1. If it gives a 1 electron to someone, okay, some atom, take it, it gives some 1 electron to some atom, so its configuration comes to 2, 8. Now this is a stable state. Why it is a stable state? There is no need for this atom to give an electron and take an electron. Okay, it is a stable state. So when an atom, suppose this is an atom, when an atom gives an electron to another atom, okay, it gets a positive charge. Okay, when an atom takes an electron, okay, when an atom takes an electron, okay, takes an electron from this another atom, it gets a negative charge. Okay, if Na is an atom, it gives electron, then what would be its charge? Of course its charge will be positive. Now on numbering, how much number of ions it have? As it releases only, it gives only 1 electron, so it will have +1 charge. It will have +1 charge. Another case, What is in another case? For example, chlorine. Okay, what is the configuration? 2 comma 8 comma 7. Okay, 2 comma 8 comma 7. It must have 8, but I am having 7. Meanwhile, if I am adding one electron to its outermost shell, it will become 2 comma 8 comma 8. It will complete its octet. So it is gaining electron from someone. Okay, he is gaining. So he is gaining some electron from some, means this is a Cl negative ion. Okay, this is gaining some electron from this atom. Okay, this is Cl negative ion. So I am getting 2 comma 8 comma 8. So it will have -1. Why -1? Minus, as he is gaining, chlorine is gaining an electron from sodium. Suppose this is a Cl and this is a sodium atom. Chlorine is gaining an atom, gaining an electron from sodium atom. So it gets a minus charge. And how much number of electron been gained? It gained 1 electron. Okay, it gained 1 electron from sodium atom to get an octet, to get a stable state. Okay, this is the point. You must remember it. Another example I can give. For example, I am taking an example of aluminum chloride. Okay, aluminum chloride. Take AlCl3. Okay, aluminum trichloride. Okay, first I am writing as aluminum has an atomic number of 13. Okay, the configuration becomes 2 comma 8 comma 3. Chlorine has a atomic number of 17, has 2 comma 8 comma 7. Okay, there are how many chlorine atoms? 3 chlorine atoms. Okay, each chlorine atoms need how much electron? 1 electron each. Okay, 1 chlorine atom needs 1 electron, then 3 chlorine atoms need 3 electrons. Okay, so if I am considering the aluminum has 3 electrons. Okay, to becoming a stable state, to complete its octet and becoming a stable state, it needs to donate a 3 electron. Okay, and this 3 electron is needed by whom? Chlorine atom. Suppose I am making the structure. Okay, I am making the structure of aluminum, chlorine, chlorine, chlorine. How much electron? Valence electron are the 7. 1 2 3 4 5 6 7. Here this chlorine atom 1 2 3 4 5 6 7. Here it come 1 2 3 4 5 6 7. And aluminum atoms have how many electrons? It has 3 electrons. This each 1 electron of aluminum atom is being paired with chlorine atom to form a ionic bond. Okay, and this being shared. So what is the charge of this aluminum? This charge of this aluminum is Al3 positive. Okay, why this 3 positive comes? Because it has donated 3 electron. Okay, and each chlorine atom, I'm not making it fully 3. Okay, I'm talking about each carbon atom. So each carbon atom will have -1 charge. So here it comes -1 charge. As I multiply -1 into 3, I get -3. Each chlorine atom has -1 charge. The 3 chlorine atoms consist of -3 charge. Here's the case. Next, we are going to talk about Rutherford model of an atom. As previously I have said about the Thomson model of an atom. Okay, I have described it, and I have also said about water ions and all. Rutherford model of an atom. This model was based upon alpha particle scattering. Alpha particles, many light consist of many particles. For photon particles, alpha, X-ray, gamma ray, many particles consist, and suggests that major part of the atom is empty. also suggests that the entire mass of an atom is concentrated on its center and the nucleus, and the electron revolve around the nucleus's close orbital. For example, okay, this is an atom. I am not taking in a spherical form, I am taking in a square. Okay, here it's a nucleus. Okay, as electron, okay, I am taking in a circular form, it would be easy to remember. Okay, it is an atom. Okay, an electron is moving. This atom's mass is being concentrated in where? It is concentrated in nucleus. It is concentrated in nucleus, and the electrons are revolving around the orbital. Okay, so the mass of an atom is concentrated in a nucleus. You need to know what was the Rutherford model of an atom. Okay, he only said that electrons revolve around the nucleus of an atom as like a solar system, as I've shown like this. Okay. This being extended by Niels Bohr, and he gave the idea about that. Every atom, every model has some limitation, like the Thomson model also have limitation, so that's why he was not considered, his structure was not considered. So next comes a Rutherford model of an atom. He takes a gold plate. Okay, it consists of many atoms. Okay, and each atom's nucleus is being concentrated with its mass. Okay, E incided an alpha particle light. Okay, I am taking a light. Okay, I am taking a light of alpha particles. Okay, here there's a nucleus, here it's a nucleus, here it's a nucleus, here it's a nucleus, like this. Check. Okay, I'm describing in another way this with a single atom. Okay, in this atom I'm taking this atom here. Okay, there becomes three situations in which, as the alpha particles have negative charge. Okay, alpha particles it has positive charge. Alpha particles has positive charge. Suppose there are this gold plate consists of many space where the rays can pass out. Okay? And there are three cases. Case 1. Okay, what happens in case 1? If an alpha particle is passing straight away from the atom. Okay, this is case 1 where alpha particles is passing straightly from an atom. In another case, what happens? This is an atom. Okay, this is an atom. It consists of nucleus. If suppose an alpha particle is crossing nearby nucleus, not touching but nearby nucleus, as nucleus consists of greater amount of positive charge. Okay, greater amount of positive charge, its nucleus consists of greater amount of positive charge. So if this alpha particle is passing somehow closer to this nucleus, then the positive get repelled and changes the direction like this. Or again we can say it is like a refraction. It's like a refraction. Refraction means, if I'm considering mirror or glass, I'm considering a light, it passes like that or it passes like that. Okay, it looks like that. If I'm passing an X-ray, okay, or I'm passing an alpha particles are positively charged. When it come close to the nucleus, as the positive repel each other, the direction of this ray changes and goes to another direction. This is a case 2. What is this? This is in case 2. In what happens in case 3? In case 3, what happens? Suppose this is an atom, this is a nucleus. Okay, this is an atom and this is a nucleus. I'm taking an alpha particles and I'm inserting incidenting alpha particles in nucleus. It gets straight hitted into the nucleus. What happens if it gets straight hitted into the nucleus? I have said earlier in the positive second case, these alpha particles are positively charged and nucleus are also positive charge. If it is incidenting into the positive nucleus charge, then it get reflected back. But here it's not the case. Here it is not hitting the nucleus, but it is somehow passing near to the nucleus, so it gets refracted and this get reflected back. These are the three cases for Rutherford model of an atom. But he said that electrons are continuous moving particle. Okay, electrons which are continuous moving particle. Okay, if electrons are continuously moving particle, okay, if electrons are considered continuously moving particle, then the electron will lose its energy. Okay, electron will lose its energy and at last it will fall into the nucleus. Okay, I have previously said this one in Heisenberg, so correct it. It is your Rutherford model. It was its Rutherford limitation. What does Heisenberg says is Heisenberg says that it is very impossible to predict the position and velocity of a moving electron. Okay, if an electron is moving, it is impossible to predict the position, or it is impossible to predict the velocity of a moving electron. Okay, please correct that one and please subscribe my channel and press the bell icon. Thank you.